Thank you for joining this session on AEC Collection for Infrastructure. My name is Camilo Jimenez, and today I'm excited to guide you through how the Autodesk AEC Collection empowers architects, engineers, and construction professionals to deliver outstanding projects from conceptual design and detailed modeling to documentation and construction management. This presentation will be highly visual, featuring screenshots and video clips demonstrating the powerful tools and workflows available within the AEC Collection for Infrastructure. Let's get started on this exploration. I won't read the entire Safe Harbor statement, but I want to highlight a few key points. You may hear some statements about our future plans. This could include the development of new or existing products, services, or our company's strategic goals. These forward-looking statements are not promises or warranties. They simply reflect what we currently plan to do based on the information we have right now. Please also remember that all the information in this presentation is confidential and proprietary. It shouldn't be shared without permission. Here's an overview of our agenda for today. We will start talking about a little bit about the context, our journey, and what Autodesk vision is. Then we will move into the three major sections. First, AEC Collection for Infrastructure, next, BIM and GIS integrations, and finally, how we are fostering the collaboration through ACC. We will end with the question and answer section, and I encourage you to note any questions as we progress, and we will address them at the end. Let's start with the Autodesk vision. AECO is one of the top 3 industries served by Autodesk, along with manufacturing and media and entertainment. Within AECO, we target the building, transportation, water, and industry segments. Our customers are diverse. They are spread across different industries and phases of the project, working in teams that are distributed. They are architects, engineers, contractors, operators, and owners. Over the past 4 years, Autodesk has led 3 digital transformations. The first was the move from hand drawing to electronic drawings with CAD and AutoCAD. The second was 20 years ago, with the introduction of BIM. It went from 2D to 3D, with a model-based approach, and was parametric 3D modeling of all AEC disciplines. At this point, BIM is no longer a revolutionary concept. It is an established industry standard. But it is still worth reminding ourselves why Autodesk and the broader AEC industry invested so heavily in this methodology in the first place. BIM leverages intelligent 3D models to capture, explore, and maintain consistent, coordinated data through every phase of the project: planning, design, construction, and operations. It delivers more accurate information about quantities, cost, schedules, and constructability, helping teams make better decisions earlier. With everyone working from the same set of consistent data, BIM improves coordination between the office and the construction site, reducing errors and rework. And perhaps most importantly, BIM empowers teams to respond to changes quickly and efficiently, enabling smarter, faster workflows across the board. So while BIM may no longer feel like a new idea, its value in driving project success is as relevant as ever. And finally, around 6 or 7 years ago, we began connecting project data to the cloud. The way we work has fundamentally changed. An unexpected event like the COVID-19 pandemic clearly showed us how critical it is to ensure access to information and real-time collaboration, regardless of location. It confirmed that the cloud is the path forward. Today, Virtually every industry has embraced this shift. Much like BIM, connecting data to the cloud is no longer seen as something innovative or cutting edge. It already happened, and now it's becoming a new standard. Let's see how the AEC Collection supports infrastructure project delivery. The Autodesk AEC Collection delivers a powerful suite of integrated tools specifically designed for infrastructure professionals in civil engineering, transportation, and utilities. The collection is organized into 5 key solution categories. Design, featuring industry standard applications like AutoCAD, Civil 3D, Revit, InfraWorks, and Forma for everything from detailed drafting to advanced infrastructure modeling. Reality capture with Recap Pro, enabling users to convert laser scans and photographs into accurate 3D models for as-built conditions and site analysis. Coordination and design review, using Navisworks Manage to aggregate models, detect clashes, and streamline multidisciplinary coordination throughout the project lifecycle. Structural analysis, facilitated by Robot Structural Analysis Professional and Structural Bridge Design, which provide advanced tools for evaluating and optimizing the performance of bridges and other infrastructure assets. Information management and collaboration with Autodesk Docs and Autodesk Drive, offering secure cloud-based environments to store, share, and manage project data, ensuring all stakeholders have access to the latest information. By bringing together these specialized tools, the AEC Collection empowers infrastructure teams to efficiently plan, design, analyze, coordinate, and deliver complex projects, while streamlining workflows and enhancing collaboration at every stage. Infrastructure projects follow a series of essential phases: survey, conceptual design, documentation and detailing, and virtual design and construction. Civil 3D plays a central role, covering nearly every step of this process, although the project might start in InfraWorks. However, other tools like Revit, Navisworks, and Recap Pro are also important at different stages of the project lifecycle, and in many cases, they complement each other to deliver a more complete workflow. A key component that ties everything together is Autodesk Docs. Included in the AEC Collection, Autodesk Docs provides a robust foundation for coordination and collaboration, offering unlimited cloud storage, so every AEC customer can manage and share project information seamlessly. For teams seeking even more advanced collaboration capabilities, Autodesk offers BIM Collaborate Pro. This cloud-based solution enables real-time coordination between software platforms and project teams. Please note, however, that BIM Collaborate Pro is available as a separate subscription outside of the AEC Collection. Additionally, Autodesk provides specialized water solutions that are invaluable for infrastructure projects. These tools support analysis, sizing, and compliance for water supply, distribution, and flood management. Like BIM Collaborate Pro, these water solutions are offered separately from the AEC Collection. Now let's take a look at some of the solutions mentioned before. Autodesk InfraWorks. It's a conceptual design tool for infrastructure. InfraWorks helps design infrastructure at an early stage with powerful visualization and data tools. We start by creating the project concept, defining roads, bridges, and site features. Next, we build the existing conditions model by combining terrain, roads, and buildings for a realistic base. High-resolution drone data and point clouds improve the detail of the terrain. With the ArcGIS connector, we bring in geospatial data like utilities and land use, which supports better analysis and smarter decisions. We refine geometry and test different alignments directly in context. Watershed analysis helps us study water flow and check environmental impacts early. We can verify conditions in real time with mobile GIS apps ensuring our model is accurate and issues are resolved quickly. Finally, we can create videos and send models to Twinmotion to produce realistic, immersive visualizations that clearly show the design to clients and communities. Autodesk Structural Bridge Design is a dedicated tool for modeling, analyzing, and designing small to medium span bridges. It is ideal for engineers who need to meet highway bridge codes and deliver accurate, compliant designs quickly. The workflow starts in InfraWorks, where we create a conceptual design of the bridge model. We then refine it into an analysis-ready model and send it directly to Structural Bridge Design. In Structural Bridge Design, we set up detailed analysis using the imported geometry. The interface is built for bridge engineers, helping define spans, supports, materials, and components quickly and accurately. We apply traffic and load conditions based on regional codes like Eurocode or AECO, ensuring compliance from the start. The software performs detailed structural analysis, including influence lines and moving loads. We get clear visuals of internal forces, stress distribution, and reactions for fast evaluation. After analysis, we run code compliance checks and design calculations. Beam and deck elements are automatically verified, reducing manual work and reworks. Finally, we generate detailed calculation reports with design assumptions, code reference, and results ready for approval. This integration from InfraWorks to Structural Bridge Design speeds up workflows, improves accuracy, and helps deliver safe, code-compliant bridges efficiently. Autodesk Robot Structural Analysis provides advanced structural analysis and simulation tools for even the most complex infrastructure projects like bridges. We started in InfraWorks, where we create a refined bridge analysis model. From here, we seamlessly export text geometry and loading conditions directly to Robot for detailed structural analysis. Inside Robot, we import the bridge model and begin setting up the finite element model, defining materials, support, and boundary conditions. Robot's flexible model setup allows us to represent a wide range of structural behaviors accurately. Once setup is complete, we generate member diagrams to see internal forces, moments, and displacements along each element. This helps engineers quickly assess the bridge's performance and identify critical zones. Next, we demonstrate adding a concrete barrier in the bridge model. Robot makes it easy to integrate additional elements like barriers, parapets, or railings, and adjust their properties. We can modify mesh density, refine loads, and control solver options to balance accuracy and performance, ensuring the model reflects real-world conditions. Finally, Robot offers support for result visualization tools. Color-coded maps and interactive diagrams show stresses, deflections, and code compliance checks, helping engineers understand how the structure responds to loads and refine designs efficiently. Robot structural analysis is a key part of the AEC Collection, giving engineers the tools they need for reliable, in-depth analysis of bridges and other infrastructure, all integrated with the Autodesk ecosystem. Autodesk Civil 3D helps you improve project delivery with faster site layout and real-time design review. You can optimize designs more easily and keep your data consistent across the entire project. It helps you follow design standards, reduce rework, and generate clear reports and documentation. And when the project changes, Civil 3D helps you to respond quickly, adjusting grading, exploring design alternatives, and speeding up updates with confidence. Let's begin with surface modeling and network analysis. Civil 3D makes it easy to create digital terrain models from survey data, drone scans, and GIS files. You can analyze slopes, spot elevations and contours, and perform real-time cut and fill calculations for grading and excavation planning. All surfaces are dynamic, so when your design changes, your volumes and contours update automatically. Moving on to road design, Civil 3D uses smart corridor modeling tools to define alignments, profiles, and assemblies. The geometry is fully parametric, meaning everything and every update when you change the alignment or elevation. This helps you maintain design intent, accelerate revisions, and keep your documentation accurate at every step. Civil 3D also supports railway design with specialized tools for alignments, super elevation, and cant. You can model track corridors with precision, ensuring compliance with rail standards and design constraints. Whether it's light rail or freight infrastructure, the workflow supports rapid design iteration and documentation. For utility design, Civil 3D includes tools for both pressure and gravity-based networks, like stormwater, wastewater, and water supply. You can size pipes, define structures, and analyze flow using built-in hydraulic tools. Civil 3D makes it easy to detect conflicts, label elements, and coordinate across disciplines. All of this is supported by our robust documentation features, automated labeling, point-in takeoff, and dynamic sheet sets, so you can deliver professional construction-ready plans with greater accuracy and speed. You may already know Autodesk Revit as a BIM solution commonly used in building projects, but Revit is also a powerful tool for infrastructure structures like bridges, tunnels, retaining walls, and culverts. In this example, we see Revit used in the bridge design workflow. After geometry is developed in the tools like InfraWorks or Civil 3D, Revit is used for detailed modeling and documentation of the structural components. Revit's parametric modeling environment is especially useful here. As you define elements like decks, piers, and abutments, the relationship remains connected, so when one part changes, the model updates automatically. What's also important is that Revit allows you to place and model reinforcement in 3D using real bars and assemblies. This helps ensure the model reflects constructive intent and supports better coordination with fabricators and contractors. All of this work is done in a shared BIM environment, making it easier for bridge engineers, structural engineers, and other stakeholders to collaborate and avoid clashes. The result? A highly detailed coordinated model that automatically generates drawings, schedules, and quantities, keeping infrastructure projects on time, on budget, and construction ready. In summary, Revit brings model-based workflows into the infrastructure space, providing the detail, accuracy, and coordination needed to deliver better bridges and civil structures as a part of the AEC Collection. Autodesk Recap Pro is a powerful tool for capturing accurate existing conditions, perfect for starting any design or renovation project. With Recap Pro, you can import point clouds from many types of 3D scanners. It lets you clean, edit, and organize that data easily. This makes it deal not only for buildings, but also for infrastructure projects, like roads, bridges, or railways, where precise site data is critical. You can process and export your point clouds to tools like Revit, AutoCAD, or InfraWorks to continue your design work. Recap also connects to the Autodesk Cloud, so you can share projects and collaborate from anywhere. By combining Recap with BIM workflows, you get better efficiency, accuracy, and control in different phases, from the survey at the early stages to the construction and as-built verification. Autodesk vehicle tracking is a specialized tool for analyzing vehicle movements and paths in road and transport infrastructure projects. One standout feature is the parking lot design tool, which helps create efficient and accessible parking layouts quickly while following safety regulations. It also includes a runabout design tool that makes it easy to create and adjust circular intersections. This helps optimize traffic flow and allows for design simulations to check if the layout works well. Vehicle tracking can also be used to analyze movements in intersections, parking areas, and even airports, ensuring safe and functional designs. Finally, its integration with Civil 3D supports a smooth workflow, making it easier to optimize road alignments and ensure that vehicles can maneuver properly in the available space. Autodesk Navisworks Manage is an essential tool for the coordination and review of BIM models in construction. With its ability to consolidate models created in Revit, Civil 3D, and other applications, it facilitates the early detection of interferences between disciplines, reducing cost and delays on site. Thanks to its integration with Autodesk Construction Cloud (ACC), we can manage coordination spaces, execute automatic collision detections, and visualize conflicts in a clear matrix, speeding up the identification of interferences. Clash Detective allows you to analyze combined models, organizing conflicts by hierarchy, properties, or level, optimizing the accuracy of revisions. Besides, with the coordination issues adding, we open models directly from ACC, facilitating access to key information. But issue creation improves communication, ensuring that everyone involved receives the information needed for a quick problem resolution. With this connection between Navisworks and ACC, project coordination becomes more efficient, ensuring a smooth execution and optimizing collaboration between teams. Navisworks also allows for 4D simulations, combining models with construction schedules to plan work sequences and improve project efficiency. Its ability to generate virtual tours and review model information collaboratively makes it an essential tool for large-scale project model management. Now let's explore our proposal for BIM and GIS integration. In a traditional view of an asset's lifecycle, GIS is typically used to manage capital portfolios. BIM processes are primarily used for the delivery of capital projects. This strategic alliance helps to unite both life cycles, which allows GIS to provide information for the realization of BIM models, and that these models in turn feedback and enrich the geospatial information of the GIS models. Autodesk and Esri have worked on a strategic alliance since 2017. What has been done so far? The first technological improvements were made by connecting desktop applications to the cloud. In this case, the cloud acts to manage the flow of data between the two sets of tools. In Autodesk's case, the ArcGIS connection was integrated into InfraWorks, our preliminary design tool that we have seen before, and Civil 3D, which is used for the detailed design also. We reviewed that before. For construction professionals, design professionals, and BIM professionals, it's now easy to upload GIS information from the ArcGIS platform, whether online or enterprise, to make better informed design decisions. With this technology, it's no longer needed to convert data formats or worry about transforming coordinate systems. Work was also done on the ArcGIS side. ArcGIS Pro can connect directly to the Autodesk Construction Cloud and connect directly to the most updated documents. DWGs, IFCs, and Revit files can be embedded directly into the Esri map environment. Now let's take a look at a real-world example. This project is in Lyon, developed using InfraWorks. The goal here is to connect the two banks of the Rhone River. So we have created a road that includes a bridge structure. We can easily visualize the longitudinal profile and cross-sections, helping us to assess the design quickly. The pillars are placed automatically with a short span by default, but we can easily adjust their spacing and configuration. Before we move forward, we want to check for any conflict with existing infrastructure like drainage network. Thanks to the direct connection to the ArcGIS Online, we can select the area and import the GIS data directly into our model. No extra steps are needed. So everything looks fine at the first glance, but we suspect that there might be some outdated data, or probably inaccurate. So to confirm that, we head out to the field using the ArcGIS data collection app. And yes, we find some differences. So we update the GIS database in the cloud, and because our model is connected to this GIS database, the changes are instantly reflected in InfraWorks. So no need to export any files or send emails. So this seamless integration ensures that we are always working with the most accurate information, helping us to avoid conflicts later in the project. The next logical step was cloud-to-cloud integration. This offering transforms AEC projects with a geospatial context, enabling users to manage risk, cost, and timelines by connecting the BIM process to location during the design, construction, and operation of large infrastructures. It enables teams to integrate and visualize project data in a single cloud-to-cloud solutions to make coordinated decisions with the stakeholders. Development is focused on coordinated documentation review, design coordination, clustering and incident analysis, and extracting metrics from all through performance dashboards. Now let's see how the AEC Collection fosters collaboration through a key component from the Autodesk Construction Cloud. Docs, which I mentioned previously, is one of the solutions included in the AEC Collection. It's important to highlight three key benefits we will achieve with the aid of Autodesk Docs. Collaboration, we will be able to provide and manage access for all stakeholders using a platform that allows us to create projects with permissions configurable by user, role, or company. We also have clear and trackable communication. We can locate, assign, and track issues, add markups and comments, create review workflows, and generate and send transmittals. And also we will have coordinated information sharing. The information stored in the Autodesk Docs can be integrated with Collaborate Pro to ensure that models are fully coordinated and that information is properly shared across disciplines. Here is a snapshot of how Autodesk Construction Cloud is configured, and we can see how the Autodesk Docs plays a key transversal role in this structure. The Autodesk Construction Cloud is a powerful solution with a robust administration module to control and manage access to this information. It also includes an additional insight layer that provides reporting and dashboards to support informed decision making and give full control over the project performance. On top of that, there is Docs, the foundation where all files and models are stored. It offers full version control and helpful features such as file naming standards, review workflows, and transmittals, making it a comprehensive document management tool. Beyond Docs, there are additional modules that connect directly to the information stored with it. While these are not included in the AEC Collection, they are worth mentioning as they extend and enhance our capabilities, offering additional support and features across both the design and construction phases. Autodesk BIM Collaborate Pro is a cloud-based solution that enables real-time collaboration across different disciplines and locations. It supports design collaboration, coordination, and class detection to ensure models are aligned and fully coordinated. Autodesk Takeoff, a quantification tool that allows teams to perform both 2D and 3D takeoffs from a single platform. It ensures more accurate quantity estimations and helps improve cost planning during pre-construction. And Autodesk Build, a construction management tool that connects the office and field. It includes tools for project management, quality and safety, RFIs and submittals, and progress tracking, ensuring that the project execution is aligned, accountable, and transparent. Autodesk Docs is a cloud-based platform that allows users to organize the documents in a clear structured hierarchy with a granular access controls to ensure security. Its integrated viewer supports multiple formats, making collaboration and document review easy and efficient. The platform supports customizable naming standards, including ISO 19650, and offers advanced tools to verify documents compliance. Approval workflows and transmittal sheets are simplified, ensuring full traceability throughout the project. markups and issues can be easily documented and tracked, both within Autodesk Docs and indirectly in softwares like Revit or Navisworks. Customizable dashboards and reports give teams a clear overview of project performance. And finally, Autodesk Docs enables seamless document sharing among team members, boosting both collaboration and productivity. Here we can see some additional information about the modules included in the Autodesk Docs. One of these is administration. In the Autodesk Construction Cloud platform, we have two levels of administration, account and project level. The administration console allows you to create and manage projects, manage access to project data, manage project members and access to the different modules and folders and information, and also organize the data structures. Now that we have seen how Autodesk Construction Cloud is structured and how Autodesk Docs acts as a central repository, let's look at how we can leverage the data we are storing there. This is where the insights come in. The Insights module is all about turning project data into actionable intelligence. It brings together dashboards, reports, and analytics in one place, giving each team member personalized visibility into what matters most to them. It helps teams proactively manage risk by identifying trends and issues early, whether that's missed deadlines, unresolved RFIs, or coordinated clashes. It is not just about looking back, it's about predicting and preventing problems before they escalate. What makes this powerful is the level of customization. Whether you are a project manager tracking progress or an executive looking at company-wide performance, the system adapts to provide clear, relevant insights. So instead of reacting to delays or quality issues after they happen, teams can make faster, smarter decisions driven by real-time data to keep the project on track. Autodesk Docs is more than just a file repository. It's a robust document management environment designed specifically for AEC workflows. Let me walk you through some of the key capabilities. First, it offers a customizable folder structure with specific access controls. This means that you can tailor the document organization to your project needs and control exactly who can view, edit, or upload files, either by user, role, or company. Another interesting feature is the version control and the visualization. Every file updated is tracked automatically, and previous versions are always retained. This ensures that everyone is working on the latest version while maintaining a full audit trail, and the built-in viewer supports over 80 file formats without needing native software. For standardization, Docs supports naming conventions aligned with the ISO 19650 or your own internal system. This enforces consistency and reduces errors in file handling. And we have also the retention area, which helps us keeping the consistency of the file naming in our project. And finally, the document approval workflows allow you to formalize review and sign-off processes. You can route files through predefined workflows with clear responsibilities and timestamps, helping ensure compliance and compatibility. All of this combines to give you a centralized, secure, and controlled environment for managing project documentation from design through construction. One of the key strengths of Autodesk Docs is how it handles the version control, ensuring that everyone is working from the most current version while preserving access to the full version history. First, we can instantly distribute the latest documents and drawings to all stakeholders. There is no need to email updated files or manage separate copies. Everyone on the project sees the current version at the moment it's uploaded. At the same time, we can also view all previous versions of documents, drawings, and models. This gives us full traceability and allows us to understand how files have evolved over time. And to make version comparison easy, AEC provides a built-in tool to compare sheets or versions side by side, with visual indications for additions, deletions, or modifications. This makes it faster and clearer to understand exactly what has changed between the different versions. And in short, the version control in ACC helps reduce mistakes, supports accountability, and ensures that the teams always have access to the right information without the version chaos. A very interesting feature in the Autodesk Docs is the file naming standard, which helps ensure consistency and compliance across all project documentation. Project administrators can create or adjust a structure naming convention tailored to the project needs. What's useful is that changes are made, the preview updates in real time, showing exactly how the file names will appear. This helps avoid confusion and ensures that the format is applied correctly before enforcing it. Administrators can also decide whether to apply the standard to specific folders or subfolders, or whether to enforce the naming rules strictly or keep them a bit more flexible depending on the stage of the project. Lastly, from the same setting area, you can also choose enable or disable the retention area, adding an extra layer to control the files that are uploaded and compliant with the file name we are setting up. This feature becomes especially powerful on large projects or those requiring compliance with standards like the ISO 19650 by automating a structure and minimizing manual errors in file management. In folders where a naming standard is enforced, Autodesk Docs helps maintain control and consistency through a built-in validation system. When users try to upload files into these folders, they will be prompted by the validator if any of the file names do not meet the defined naming criteria. And from there, users can edit file names individually or in a bulk, making it easy to correct multiple files quickly without needing to re-upload it. They also have the flexibility to add or remove files during the upload session before confirming the changes. And once all files are correctly named and validated, they can be uploaded directly to the destination folder. However, if a user hasn't finished validating all files, instead of discarding or delaying the upload, they can send those files to a special holding space called the retention area. This allows them to complete the validation later while keeping the upload organized and traceable. This mechanism not only supports the ISO 19650 compliance, but also enhances quality control by ensuring that only properly structured documents make it into the live project folders. In Autodesk Docs, we can set up customized and automated preview workflows that streamline the way project drawings, models, and other documentation are distributed and approved. These workflows allow us to automate the review process, ensuring that all files move through a predefined path from authoring to review and to final approval, without the need for manual coordination. This helps reduce delays and reinforce accountability. Project teams can collaborate within the platform using a built-in tools to comment, mark up, and provide feedback directly on the documents. This keeps all documentation centralized and avoids the confusion of external emails or disconnected systems. Once reviewed, files can be easily shared with the relevant stakeholders, ensuring that everyone is working from the most current version of the document. The combination of automation and platform collaboration increases transparency, consistency, and speed across the document review lifecycle. In short, with ACC, we will have better collaboration, communication, and coordination. And all of these will be achieved by connecting to a platform that enables an ecosystem with improved workflows. An open and connected platform allows us to leverage our strategic partners, enabling a more transparent flow of data and better interoperability with other solution providers in our industry. As an example of how ACC enhances interoperability and connectivity, this slide highlights the strength of Autodesk Construction Cloud's strategic partnerships and its rich integration ecosystem. ACC offers seamless integration with a wide range of third-party solutions, spanning areas such as reality capture, financial and budget management, project controls, health and safety, and project management. These integrations allow external systems to connect with and leverage the centralized data stored in ACC, enabling more efficient workflows, reduce data silos, and also better informed decisions across the project lifecycle. Thank you for your time and attention today. I hope this session gave you a better understanding on what the AEC Collection can do to improve the efficiency in infrastructure project delivery. I'm happy to answer any questions you may have.